Hello everyone, we're going to be answering the following question, and it states, burning dirty coal produces sulfur dioxide, among other pollutants. Sulfur dioxide is oxidized in the atmosphere to produce sulfur trioxide, which subsequently combines with water to produce sulfuric acid, a major component of acid rain. Draw all possible resonance structures of sulfur trioxide. So before we answer this question, let's first ask ourselves, what is a resonance structure? A resonance structure is two or more equally valid Lewis structures that can be drawn to represent more accurately the actual structure. And so when we draw these resonance structures, they're only varying in the position of the electrons that are distributed amongst the structure. Let's go ahead and answer this question and practice drawing resonance structures for sulfur trioxide. So the first thing that we have to do is draw a Lewis structure. Once we draw the Lewis structure, we can then draw out each resonance structure that is readily available. So first things first is valence electron. We know sulfur and oxygen all lie in the group 6A, so they each distribute 6 electrons. So 4 times 6 is 24 electrons that we need to distribute. In this case, sulfur is my central atom. I draw my skeletal structure, and then I distribute all my electrons. We know we have 24 divided by 2. That's 12 electron groups. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. Let's go and check to see if we have an octet for each of our atoms. So in the case of oxygens, we have 2, 4, 6, 8, 8 electrons. In the case of sulfur, we have 2, 4, 6. So sulfur does not have its octet. So what we can do is we can form multiple bonds by taking a lone pair and drawing a multiple bond from it. So if we were to do that, we get something of the following. However, you must be asking yourself, or what you probably did on your own, was you might have made a double bond on this atom or over here. It doesn't really matter because this is where resonance comes into play. Oops. You could have drawn the double bond to the oxygen on the left, or you could have drawn the double bond with the oxygen on the bottom. Remember, each of these resonance structures are all correct. All we're changing is the location and the distribution of the electrons. Thank you.